Hello students, good morning, good afternoon, good evening, or good night to you all. Welcome back to another video from the Apex Institute of Mathematics Education. My name is Akin, your math instructor. Of course, my channel primarily based on providing contents regarding tutorial videos on a variety of concepts in math, but primarily I focus on the curriculum of the Caribbean Examination Council, that is CSEC, as well as CCSLC, SEA, and or ED Excel exams. I also do a few tutorials on City and Guilds, past papers, and solutions. Before we get into the primary focus of the video, if this is the first time here on the channel, do not forget to hit the subscribe button below. Leave some positive questions and comments. Leave some video requests. Of course, make some suggestions. I would love to hear your thoughts. If it is that the video is of any value to you, do go ahead and smash that like button. It really does help the channel to grow. Alright? So, of course, as I said before, primarily I focus on the curriculum of the CSEC exams. So that's what majority of my contents will be about. Now, in today's video, we're going to be looking at a very fundamental concept in math, something that I find a lot of young students who have perhaps gone through the grade 5, 6, 7, 8, even grade 9 level of math, and I still find that students struggle when they have to deal with what are known as directed numbers or integers. There are a lot of ambiguities in their understanding of integers whenever it is that they are adding or subtracting them, or when they are multiplying or dividing them. And I've been teaching math for the better half of 10 years, so I've experienced this with a lot of the type of pupils that I teach. So I primarily decided that I'm going to be developing this particular video here to help you clear up some of those ambiguities, as well as, of course, fundamentally rebuild your math skills. Now, of course, math can be a challenge only if you want it to be, because with strong fundamentals, rock solid foundation in math, then as you go higher and higher and higher in the level of math, you will find that a lot of these skill sets will be required to be a more efficient student. Nevertheless, let's jump right into today's video tutorial and let's see what we can learn. Now, we're going to be starting off generally with the definition of what is an integer. And of course, an integer, sometimes referred to as directed numbers, can be written in a simple definition of that an integer or integers are a set of positive and or negative whole numbers starting from minus infinity all the way to positive infinity. Now, usually you're gonna find in formula books, textbooks, and or on practice papers, you're gonna find that majority of the time we indicate the set of integers using the symbol z or the symbol I. So you can find here a lot of the times that z or I will be our indicator. So therefore we can say that z equals the set of and so on, minus 3, minus 2, minus 1, 0, 1, 2, 3, and so on to positive infinity. So because obviously I don't have all the space to write out all the integers, which obviously is infinite, I just listed a few starting from minus 3, ending at 3, and putting some on so and so on sign here. to show you that it continues infinitely in both directions. Now, I'm going to be walking you through two methods in which are two mental methods in which we can look at this. One will be the textbook definition of how to look at integers, and one will be a more realistic approach towards the question, something that you have to deal with on a regular basis. Now, whilst a lot of students, higher level students, would have been watching this video and would say, hey, there are many ways to look at integers, I choose to use these two methods because I find that they are very, very effective at this level and can also be very effective as you go higher and higher up. This particular lesson here has a lot of advantages when it comes to heading into various aspects of math, such as simplification of algebraic expressions, multiplication and or division, addition and or subtraction. But here we go. Of course, guys, let's get into it. Now, one of the common rule when it comes to integers would have been that if two integers have the same signs, then the rule is that we're going to be adding both of the numbers and we're going to be keeping the common sign. And the common sign would be the sign, obviously, that is on both of these values, or both are on all of the values that are being that are in the sum. Okay, now let's take it fundamentally. I'm very, very adamant about building and rebuilding the fundamentals of students. So if we can approach math from a fundamental perspective, no matter the difficulty level of the math, then you're gonna find a lot of the times that the math becomes easier and easier as you go higher and higher. Now, let's take, for example, a very simple math here, which is gonna be, of course, 3c plus 4. All right, and it's key to note that here 3 is a positive 3, so it's very important we remember that. And now if you notice here that both the 3 and the 4 have the same sign, positive 3, positive 4. Now naturally, without even the use of a calculator, then most students at any level will know that the value of this here is positive 7. Hence why we keep the common sign, because the common sign of the 3 and the 4 is positive, so we keep the positive sign and we add the 3 and the 4. Very simple, nothing too complicated there. Now let's look more at an example that I find, and I'm not sure if you are the type of student that find an issue with this, is that if a student gets, say for example, negative 4 minus 2, for some reason I find that a lot of students tend to ignore the sign and they visualize this number here as just being 4. And so what I've always advised my pupils, that whenever you have a sign that is in front of a number, that sign belongs to the number. So it's crucial here that we remember that this is not 4 take away 2. This is negative 4 take away 2, or negative 4 minus 2. Now, I've given students this so many times at the fundamental level, and what I've find here is that they often give me a variety of answers, like say they'll tell me that the answer is negative 2, they'll say that the answer is positive 2, and of course some students who obviously know what they're doing will give me the correct answer here of minus 6. So we're not, the lesson here is not particularly about what is the answer, but is the approach towards getting the answer. And so using the textbook method of working this out, you'll realize that here that the common sign here is negative, so we are in fact going to keep the negative sign here, and we're going to be adding both numbers. Then you might ask, why are you adding if you're clearly seeing a subtraction sign? Because what's really happening here is that we are adding -4 to -2. That's really what is happening. So when you're adding something negative to something that is already negative, it's going to become even more negative. So that's exactly why we are really adding, okay, by using some sign manipulation. So therefore the answer here would have been that 4 plus 2 is 6. And so because the common sign between the numbers is negative, then we're going to keep a negative sign. All right, so that wasn't too hard at all, and I find that a lot of students, when you give them this form of method in working these problems out, then they sometimes get it mixed up. I'm not sure why, but I'm hoping that this video clears up exactly why, and so you can move forward with not making these fundamental mistakes. Now, we've just looked at when the signs are the same. So what happens then when the signs are different? So here it says that the common rule is that if two integers have opposite signs, we are going to subtract the smaller number from the larger number, and we're going to keep the sign that is attached to the larger number. Let's take a look at two examples, two very basic examples. So here, now we're looking at, say, 15 take away 19. I find that a lot of my students, especially at the lower level, fundamentally, even I've taught students who have gone past the, say here, grade 10, the grade 11 level, and I find a lot of students still struggle with this very basic aspect of math. Now, in order for us to approach this and to always be able to know that our answer is correct, is to, of course, remember the common rule. So here it is key that we note that the 15 is in fact a positive 15. There isn't a sign in front of it, but it is understood as a positive 15. So it's safe to say that this particular arithmetic here has opposite signs. So what do we do when they have opposite signs? We are simply going to take away the smaller number, which is 15, away from the larger number, which is 19. So mathematically, if we were to take 15 from 19, we would end up with 4. But it also said here that, and we are going to be keeping the sign that is of the larger number, or it's going to be attached to the larger number. So the larger of the two is in fact 19, and 19 has a minus in front of it. So therefore our answer is going to be equal to -4. All right, so hopefully if you can approach the problem from that direction, then you should be okay. Now let's look at the other way that we can have this question here. We can perhaps say here that we have -12, say, plus 7. Let's look at this problem then. So now once again it is clear that we have opposite signs. Okay, in the first example we had an implied positive sign here, but now it's clear that the 12 is in fact negative and the 7 here is positive. So we have opposite signs, and according to the common rule is that if two integers have opposite signs, which is exactly what we have here, we have opposite signs here. So we're going to be taking the smaller number, which is 7, we're going to be taking that away from 12. So if we take 7 from 12, however you want to calculate it, you should end up with 5. So what happens then? We're going to be keeping the sign of the larger number. So the larger of 7 and 12 is in fact 12, and 12 has a minus sign in front of it. So our answer here is -5. Okay, so that is how you're going to always do the problem. And this is generally how you're going to find a lot of math teachers will teach you when it comes to directed numbers, or what I would refer to as operations with integers. So that is now the textbook way. Now I'm going to be introducing to you a method. It's a mental method, a realistic method, in which I've been using for the better half of, say, 5 to 6 years, and I've gotten a lot of good reviews in terms of students not being able to comprehensively work out problems like these at the fundamental level. Once I've gone through this explanation with them, they tend to gravitate towards this method, and it is called the OHAV method. And so with the OHAV method, we are taking a more realistic approach towards the problem. We are looking at the numbers as if they were perhaps, say, money. Okay, I know that a lot of students, they are very interested in calculating currencies. So if we can take a currency approach, a monetary approach towards the math, then you're gonna find, I think, more consistency in getting the correct results. Now you will see here that I placed my own definition of how to approach integers, and so here you'll see where I've explained to you that a negative number is now, and going forward, I'm assuming that you guys are going to gravitate towards this method. A negative number is perceived as an amount that is owed. Okay, so maybe you owe John $5, or you owe Mary $10, or you owe Sandy $50. Once you see a negative number, say -5, or say -8, or say -12, these numbers implies owing. Now naturally then, a positive number is now going to be perceived as something that you own. It belongs to you. It's something that you have. It is something that you possess. It belongs to you. So then if we say here +10 with a plus sign, or just if you just see a number like this, say 15, or say you see the number, say 2, just like that, then whether it has a plus sign or it doesn't have a sign in front of it, then the implied positive means that these numbers are what you basically have. So this is why I call it the OHAV method, the owing having method. Okay, now another way that you can actually look at negative numbers is also from the perspective that you may have borrowed something from someone. So obviously when you borrow something from someone, you basically owe them. But again, using the different words during your problems can actually help you to get to the answer more effectively. Now, as to why I would have actually taught a lesson like this on YouTube is because I've been teaching math for the better half of 10 years, and in every single one of my years, this is the topic that I've always started with, especially when it comes to CSET math and rebuilding students. I do crash courses in exams where I have to be teaching a bunch of topics that is supposed to be spread over a course of 2 years, over a period of 2 years, which I have to be crashing into 9 months. So these are some fundamental concepts that I have to actually go through. Now, what I've done here to bring the video to the end, I've actually came up with about 4 simple questions here that we're going to be evaluating, and of course we're going to be evaluating these without the use of a calculator. Now, there is no need for a calculator because we have the principles in our mind. I'm going to be interchanging the methods, right? The first one using the textbook method, and I'm also be using the method of the owing and having, showing you that we're going to be getting consistent results. All right, so for the first 2, you can see that I only have 4 numbers, and then I have an odd amount of numbers here, and then I have an even amount of numbers over here. So let's get right into it here. Let's rewrite our first question. We have 6 take away 11 take away 7 plus 15. For this particular example here, I'm going to be using method 1, where we're using the textbook approach. Now, remember, this is a fundamental math problem, so we're not interested in so much what the answer is, because we could easily type this on the calculator and we would have easily gotten the answer. But we want to approach the question mentally. So here's the best way to do it. We're going to be putting these numbers into groups of 2. Now, associating the numbers is also another fundamental mistake that I find students make whenever they are actually grouping or associating numbers. It's very important that you associate the sign that is in front of the number. In other words, if you were to perhaps say bracket the negative away from the 7, then this number is no longer being perceived as -7, which is what it is. It's now being perceived as +7 because the bracket goes in between the sign and the number. So it's very important you remember that once you're associating your numbers, you associate the sign that is in front of the number. Now, using method 1 here, we see that we have opposite signs. This is an implied +6 and this is a clear -11. So according to the rule that we just discussed a few minutes ago, then if we have opposite signs, we are going to in fact take the smaller number from the larger number, and we're going to be keeping the sign of the larger number. So if you were to perhaps say 6 away from 11, or 11 take away 6, would have ended up with 5. But is it negative or is it positive? Well, in this example, it is in fact negative, because the negative is the sign that is attached to our larger digit of the 2. So 11 is larger than 6, so negative is attached to the result. Okay, now another mistake that I find students make, and when I tell you that these mistakes are made often, I mean they are made very, very often, and students get so many inconsistent results over the years that I've been teaching this particular concept here. So another mistake is that we are always too quick to write down the sign that goes here. So we can't really state whether or not it's going to be a negative or it's going to be a positive until we do a thorough observation of what is going on in this bracket here. So here you would almost feel like you need to bring down the negative sign, but if you do that, you're going to find at times that the answer may end up being a positive result. Let's have a look. Here again we have opposite signs, and so with opposite signs we're going to be taking 7 away from 15, and mathematically that should give us 8. Now, is it +8 or is it -8? Well, because the 15 is larger than the 7, we're going to be keeping the positive sign, because we keep the sign of the larger number, so it is in fact going to be +8. So I find that students get a little bit flustered when they're not very confident in what they're doing, or they're not very familiar with the concept without the use of the calculator. They may sometimes write down the negative sign and add the 7 to the 15. Brutal mistake. Never want to do that. Okay, next we're going to wrap this up here and simply write down our answer here to be +3. How is it +3? Again, opposite signs. So we're going to be taking the 5 away from the 8, and we're going to be left with 3. Is it positive or negative? It is in fact positive. Why positive? Because the positive sign is a sign that is of the larger value of 5 and 8. So therefore the answer is +3. We don't necessarily need this positive here, we just know that it is 3. Alright, so I'm taking my time and I'm walking through this particular problem as carefully as I can. I could actually speed up the process, but I really want after this video, I want you guys never to have another problem when it comes to integers. So I want to clear up any ambiguity or any mistakes. I want to highlight any mistakes that you guys may make. Let's move on to example number 2. So for example number 2 then, we're going to be looking at, say here, negative 15 plus 9 minus 13 plus 5. I'm going to be using the OHAV method for this one. So what we're looking at then here is in fact grouping the numbers into pairs. So here we're going to be grouping here, grouping here, grouping here, and grouping here. We have already discussed associating the sign that is in front of the number. Next, we're going to be using the O and half technique. Now, let's approach the question from this perspective. Here, this implies that I would have owed someone $15. Let's give this someone a name. Let's say that you owed your mother $15. Okay? And this positive 9 implies that that's the amount that you have. That's the amount that you could possibly pay from what you've already owed. So clearly you can see that you would have owed more than what you have. So that simply means that you're still going to be owing, and because you're still owing, the answer is going to be negative. So if I can pay 9 out of the 15 that I owe, then mathematically I would still owe 6. I'm not sure if you like that method. Let's continue. Over here, again, I would have owed 13. And now I would have only have 5 to pay. I can only pay 5 because I possess the 5. I have 5. I can pay what I have. But even after paying what I have, I'm still going to be owing. So I'm going to be owing a possible 8. Next, finally wrap this up then. This would simply mean then that I would have currently owed 6, and I would obviously owe another 8 onto that 6 that I already owe. So therefore then I would have ended up owing 14. Okay, again, as I said, students make fundamental mistakes like taking away the 8 from the 6, getting 2 and writing negative 2. We want to look at the number for what it is. Remember that a sign that is in front of a number belongs to the number. Let's move on here to example number 3. Alright, here we go. So now we have an additional digit attached here. Now we have negative 7, take away 9, plus 12, minus 20, plus 2. Okay, now again we're going to be associating the numbers into groups. So here, associating the negative 7 with the 9, the positive 12 with the negative 20, and there's nothing to associate the 2 with. So this 2 is going to always come down until there's a pair that it can be associated with. So that's an odd digit, odd integer that we have outside. So let's just wait for a digit to be paired with that. Here we can use method 1, and like I said, method 1 is more of a textbook, more textbook type method, right? If you, as a matter of fact, I would love for you guys to leave a comment down below as to which method do you find work for you. Let me know in the comments down below, what do you prefer? Alright, so here I owe 7 and I owe 9. So if I owe 7, pardon me, I think I'm using method 2. We did say we're going to be using method 1. Let's go again. So for method 1, here we have same signs. So we're going to be keeping the sign that is common, which is negative, and we're going to be adding both numbers. So if you were to add, say, 7 to 9, you're going to find that our answer here is 16. Well, in fact, it is negative 16. Here in this blue bracket over here, you're going to find here that we have opposite signs. So with opposite signs, we're going to be taking the smaller value away from the larger value. So right away, 12 away from 20 will give us 8. But is it positive 8 or is it negative 8? Well, it is in fact negative 8. Why? Because the negative is the sign that is attached to the larger of the two values. Then here, this positive 2 comes down. Now, very importantly, that I also mentioned that when you're associating or grouping your numbers, I tend to always group my numbers from the left side. But that doesn't mean that you cannot group the numbers from the right side. If I wanted to, I could have actually grouped here negative 8 with 2. But what I find when students try to go against moving from left to right, they sometimes will make an error where they accidentally group the 8 like that. So I really don't recommend you trying any experiments with this. I do recommend that once you're associating, just associate from the left towards the right. So now what we have here is in fact minus 16 minus 8. We're still using method 1. Here I have the same signs. So now I'm going to end up having a negative answer again. Then I'm going to be adding the 16 and the 8. Please be reminded that negative 16 minus 8 is really negative 16 plus minus 8. That's the reality of what's happening. That is why you keep hearing me saying I'm going to be adding both numbers and keeping the common sign. So hopefully you're not confused as to why I said I'm going to be adding both numbers, because that's the rule. We add both numbers and keep the common sign. So we end up with minus 24 here. And finally, that number 2 here, that value 2, which was at the beginning of the question, finally now has appeared. Now we end up with here opposite signs. So again, reiterating the rule that we're going to be taking the smaller number away from the larger number. So in fact here, if I take 2 away from 24, I should get 22. But is it negative or is it positive? Well, it is in fact negative. Why? Because the negative is a sign that is attached to the larger of the two numbers. So because the 24 is larger than 2 and the 24 is negative, our answer will remain as negative here. All right, beautiful. So we're on to the last question here. Now we ended up with 2, pardon me, yes, we have 2 minus 19 plus 13 minus 21 plus 25. So here's what we have. Final question. 2 take away 19 plus 13 minus 21. I think I might have made a mistake. Plus 21 plus 25. Okay, so it's plus 21. So it's minus 21 plus 25. Alright, there we go. So once again, let's quickly wrap this video up. We're going to be putting this into groups of 2 here. Now it also must mention, and you can see that there's a lot of things that you guys are learning in this particular video here. Earlier when I said to you that associate the sign with the number that it is in front of. For the negative sign, it can significantly affect your answer. Now for this particular example here, even if I had somehow fundamentally not focused, not paying attention, not looking at what I'm doing, and I made a mistake and I perhaps say here group out this, well, in this particular example my answer will not be affected, because whether I group the positive sign or group out the positive sign, this number is still perceived as what it was in the initial stage, which is a positive 13. But once again, I do not encourage you to practice to try stuff or to do anything funny when it comes to the math. It is best that you find one approach that works and stick with it. So if we're going to be grouping, let us practice to group our signs with the number that is attached to it here. Once again, we have this odd value waiting to be paired. Now we're going to be using method 2, which is the O1/2 method. So I'm fluctuating the methods that I'm using just to show you which one is effective. Again, I'd love for you to leave your comments down below, guys. If you're watching this tutorial video, let me know which method works for you. Here I owe someone $19. Remember that there is no sign that is in front of the 2, so it's an implied positive sign, and this is clearly a negative 19. So this would simply mean that you perhaps say, oh, your best friend, or you owe John, or you owe Tom $19, but you're only able to pay 2 out of that 19, because once you have any amount of money, then you should be able to pay what you have. So by paying the 2 that I have from the 19 that I owe, then mathematically I'm still going to be owing 17. So I'm going to be owing 17 here. And it's very important that we do not be quick to write down the signs. So do not get rushed and write down a plus sign here, because you might find that just that one error there is what throws you off completely. Remember, I've had students over the years explaining to me that the signs are what gives them problems, but because when you rush, then rushing will cause you to make fundamental errors like this one. So here, quickly, 13 minus 21. Once again, let's say you owed your father $21. You owed someone $21. All right, and let's say you only had 13 to which you could pay. Okay, so I'm still going to owe, because I obviously don't have as much as I owe. I owe way more than what I have. So basically, I'm still going to be owing a total of 8 here, plus then 25. Then we're going to be grouping again from the left side here. So now what we have is minus 17 minus 8. I now have owing. So I owe, basically you can visualize this as you owing 2 different persons. You then owe, say you owe Sarah $17, and you then say here you owed say Mark $8. So how much do you owe Sarah and Mark together? Then you obviously owe them both 25. And I'm so happy that this example came up, because it's something that we haven't talked about. It is something that is known as the additive inverse identity. And so the additive inverse identity states that if you add a particular number to its opposite sign, let's say like what we have here, we're adding negative 25 to positive 25, guys, obviously this would never be equal to 50 or negative 50 or whatever it is that you're going to come up with. It is in fact equal to 0. Why? Obviously the same amount that you owe is the same amount that you have, so you can pay what you have to clear the amount that you owe. Therefore you have nothing and you owe nothing, so therefore your answer here is 0. This is known as the additive inverse identity. All right, so that brings us to the end of this particular tutorial. A pretty lengthy one. I could have gone a bit faster if I wanted to, but I really wanted to take the time out to really go through all the little areas that you students may have overlooked. Now I do hope that this particular tutorial here was of some value to you. Do not forget to hit the subscribe button below. Share the content out to your school groups, your friends that may be struggling with math, anyone who you know who always be complaining and arguing that math is a challenge. This is the channel for you. If you want to become a serious math student, if you want to become stronger math student, if you want to improve your math skills, if you want to develop your mental ability to do math, then you definitely want to become a part of the Apex Institute of Mathematics Education family. Alright, lots of stuff will be coming out on the channel. Exams are coming up. I'll be having past paper solutions paper, so do look out for that. And there's also going to be some fun contents when it comes to numerical manipulation. So I'll see you next time in another tutorial video. So until then, take care. Bye bye.